Hello. Hello. Today let's have a small discussion on the eigenvalues and the eigenvectors of a square matrix. I hope that all of you know something about a matrix and what is a square matrix. A square matrix is nothing but a matrix with rows and columns equal. Such a matrix will be called as a determinant. Now we shall discuss the idea about the eigenvalues, eigenequation and the eigenvectors of a given square matrix. Let A be a square matrix, Aij n cross n. Now this is a square matrix. Then there exists, this one I will put it as there exists non-zero column vector and a scalar such that Ax is equal to lambda x. So it has been found that if A is a square matrix, then there exists a non-zero column vector x. A column vector, by which I mean the vector having some n components. If it is a n cross n matrix, n components. So a vector, a scalar such that, and a scalar is just a number, see, and a scalar, I will put it here, a scalar lambda, scalar lambda such that Ax is equal to lambda x. Now this can be written as Ax minus lambda x is equal to 0. This can be written as A minus lambda I of x is equal to 0. This I is n cross n unit vector, unit matrix. This is I will be an n cross n unit matrix. Unit matrix in the sense along the principal diagonal ones and zeros elsewhere. This is an idea you should be having. So with the assumption that you know these things, I am telling you that this is a matrix. Now, so this is A now. A minus lambda I modulus of this, determinant of this is equal to 0 is called eigen equation or characteristic. This is called A minus lambda I, which is equal to 0, is called the characteristic equation or eigen equation. And that the values of lambda that we get in solving this, we have to solve this equation. If this equation is solved, then if it is since A is an n cross n matrix, we will find that there will be n number of eigenvalues. That means lambda 1, lambda 2, lambda 3 up to lambda n number of eigenvalues will be there. Lambda 1 dot 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 lambda n eigenvalues. And all of them need not be distinct. They can all be different zeros and something like that. Okay. Now, so these are called the eigenvalues, and this is called the eigen equation, and that corresponding to every lambda I, we can get hold of an eigenvector. We can get, see x, I told you here x vector. See, I can get for every lambda I can get hold of a eigenvector, and that eigenvector need not be unique. In the sense, the components may be of, it can be of anything. That means it need not be unique. So what I want to tell you now here is that if A is a square matrix, then there exists a column vector x and a scalar lambda such that Ax is equal to lambda x. This can be written as Ax minus lambda x is equal to 0, A minus lambda I of x is equal to 0, where I is the unit matrix, n cross n unit matrix, and this A minus lambda I is equal to 0. Determinant of that is called the characteristic equation or Eigen equation. If this equation, this is a polynomial, right? Understand that this is a polynomial. If this polynomial is solved for lambdas, since it is a nth degree equation, you will have n number of values, lambda 1, lambda 2, lambda 3 up to lambda n, and they are called the eigenvalues. And incidentally, note that for every lambda I can get a eigenvector, and eigenvectors need not be unique, is not unique. So these are the basic ideas that you must have about the eigen equation, eigenvalues, and the eigenvectors. Now I will give you the method of finding the eigenvalues. We will take this session to give you the knowledge of how to find the eigenvalues. After then, I will tell you how the corresponding eigenequations, eigenvectors can be found taking the values of the eigenvalues. Now, I will take an example on that. So, example, I will write here. Find the eigenvalues of the matrix A is equal to 3 minus 1 1 minus 1 5 minus 1 okay. Now let's try to find the eigenvalues of this. I told you that this is a 3 cross 3 matrix, a square matrix. So naturally there will be 3 eigenvalues corresponding to 3 eigenvectors. So these are the basics that I remember. Now see, the eigenequation is, what is that eigenequation? Eigenequation is A minus lambda I mod of that is equal to 0. So this is your eigenequation, where lambda is the eigenvector, eigenvalues, and these eigenvector, the corresponding eigenvalues have to be determined. Now let us determine the value of this. Now I can write this as, what is that? A minus lambda I, 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3, this minus lambda, and I told you that if it is a 3 cross 3, given matrix is 3 cross 3, your unit matrix should also be of the same order. So what is it will have? 1 0 0 0 1 0 0 0 1. Now this is equal to 0. Now this is, find the determinant of this. So you have to take the determinant of this. If you find the value of this, now that will give you, if you convert this, that will give you a polynomial here, third degree equation in lambda. Solve that, you will get the values of the values, lambda 1, that is values for lambda 1, lambdas. So what that you have to do is, so this is nothing but 3, I'll straight away write this 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3, and this will be minus multiply. You multiply lambda with every element there. Okay. Now what is it? You'll have lambda 0 0 0 lambda 0 0 0 lambda. So this is what you get. Now what is that you get? Now you have got this. So I'll rub off this. See. Now this is nothing but 3 minus lambda, and this is minus 1 1 minus 1 5 minus lambda, and this is minus 1, and this is 1 minus 1, and this is 3 minus lambda. Okay. So this is 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1, and this is 1 minus then 3. So this is the equation that we are having, and it has to be solved. So which one has to be solved here? So this is what I have. So this equation has to be solved. Now how to solve this? You find the determinant of this. You get how to find the determinant of this? 3 minus lambda into 5 minus this is 15 minus 8 lambda plus lambda squared, it is minus 1. Minus into minus is plus, minus 1. Then minus into minus is plus 1. Then this is multiply this and this, minus 3 plus lambda. Then this is 1 into minus 1 is plus 1, so this is 1. Then plus 1 into minus 1, okay. Then it is plus 1 minus 5 plus lambda. Now what you have to do is collect the coefficients of lambda cubed, write it in the descending order: lambda cubed, lambda squared, lambda, and then constants. Now if you do the simplification here, what I mean is that you go for this minus lambda cubed, then you collect the coefficients of lambda squared plus lambda squared. Collect the coefficients of lambda squared here, it is plus 8 lambda square, so it will be 8 lambda square. Then plus 3 lambda square. Then collect the coefficient of lambda, so minus lambda into, it is 15. Then it is 15 minus 1 is 14. So you'll have minus, see, 15 minus 15. Sorry, here 15 minus 1. 15 minus 1 is 14, so 14. 15 minus 1 is 14 lambda. Then here minus 24 plus 24. Then constants 3 into this is 14. 14 means 42. Keep this minus 2 plus lambda minus 4 plus lambda is equal to 0. So what is that you'll get here is minus lambda cubed plus 11 lambda. Here 38, and here you have got here see 38. Then 2 lambdas are there. This is minus 38, so minus 36. Then you have got here 42. Then this is minus 6 plus 36. 0. Now this is the equation which has to be solved for lambda. So what is the meaning of this? This is a cubic equation. Solve for how many values will be there? 3 values will be there. So since it is a given matrix is of order 3, you have got 3 values for lambda. So correspondingly 3 vectors will be there. Okay, and this has got a very high importance because in course of time when I take this, when I extend this further in the subject, then I will tell you how this values help us to find the eigenvectors and also ultimately get the diagonal matrix. Getting the diagonal matrix is very, very important. So finding the values of this lambda and getting the corresponding eigenvectors, then it ultimately leads us to find the diagonal matrix. Okay, so for that only we are finding. Now let us stop with finding the eigenvalues here. Now, so this is what you have. Now this has to be solved. Now I will give you another method of doing it. So this is nothing but you can write throughout, multiply by minus sign. So lambda cubed minus lambda plus 36 lambda minus 36 is equal to 0. Now, so this is what you have. Now I will give you another method of doing this so that let us verify whether what we are, because there can always be a slip of the hand, that is we may count it wrongly, addition, subtraction may be wrong. So but anyhow we must get it correctly. So let us verify whatever we have got here as the lambda equation is correct. Okay, how to do that? So now let us come to this. As I told you, this is a cubic equation. So you start with lambda cubed minus lambda squared, then come to this, add the diagonal elements. See, add the diagonal elements, 3 plus 5 plus 3, then alternately plus lambda. Now you see that 3 plus 5 plus 11 lambda it has come. See, we have got here minus 11 lambda squared plus lambda into what is that you must do is you get the determinant value of the minors corresponding to every diagonal element. Can you catch what I am telling you? You have to get the determinant value of every element in the principal diagonal element. See, for example, this is your 3. Suppress this, suppress this. What is the minor? 5 minus 1 minus 3. You get the determinant value. 5 into 3 is 15. 15 minus 1 is 14. So write it as 14. Then come to the second element here. 5 is your principal diagonal element. Suppress this row column, suppress this row. 3 into 3, 9. 9 minus 1 is 8 plus 8. Then come to this 3. Suppress this column, suppress this row. 5 into 3 is 15. 15 minus 1 is 14. So it is also plus 14. Minus. Now you add this. 14 plus 14 is 28. 28 plus 8 is 36. I am getting 36. Okay. Then minus. Now you have to get the A determinant. That is determinant of A. How to get the value of determinant of A? 3 into 5 into 3 is 15. 15 minus 14 is 14. Then minus into minus, second element is plus 1 into, suppress this column, suppress this row, minus 3 plus 1, it is minus 2. Then plus 1 into, suppress this column, suppress this row, minus into minus is plus, this minus, it is minus 4. So what is that you get? 42 minus 2 minus 4, that is equal to 36. That is your determinant value. So what is the value of this determinant value? 36. You are getting 36 here. So it is minus 36. So, and here it is what? Lambda cube minus plus minus plus, alternately it goes on. So these two equations we are getting correctly. So our characteristic equation is perfect. Okay. Now let us find the lambda values. How to find the lambda values, I will tell you. Let me rub off this. Now we have to solve this. We will take this as 1. Solve 1. Solve 1 means find the values of lambda. Now 1 means the same thing. you can call this as 1. Okay, yeah. Now what is that? Lambda cube, let me finish it, minus lambda square plus 36 lambda minus 36. Now try to find the roots of the equation. If you find the roots of the equation, then you can get the factor. If lambda is equal to 1, try lambda is equal to 1. Don't take lambda is equal to 0. It's a trivial, let us not. Even if you take lambda is equal to 0, you will get that it is not, this equation is not becoming 0. So try lambda is equal to 1. 1 means 1 minus, this is minus 11, 36, my 36, then this will not become 0. Substituting lambda is equal to 1 does not make this 0. So lambda is equal to 1 is not a solution. Okay, try lambda is equal to 2. Let lambda is equal to 2. Take lambda is equal to 2. So what is that you will get? It is 8 minus 44 plus 72 minus 36. Now add this. 72 plus 8 is 80. 36 plus 44 is 80. So this is plus 80 minus 80. This is equal to 0. Therefore, lambda minus 2 is a factor of 1. So it is a factor of 1. Now since this is a cubic equation, you must have other factors. That means of degree 2. Can you understand? So it may be linear like this. It is lambda minus 2. It's a linear factor. I can get another 2 linear factors. So what are those linear factors? The methods are just by inspection I can find, or use the synthetic division to find the other roots. How to find the roots of by using the synthetic division? Now this is a factor. I'll close it. Now what is that you must do is take only the coefficients 1, minus 11, 36, minus 36. 2 is your factor, put 2, then 1, 2, minus 9, minus 18, 18, then it is plus 36, 0. So what is that you get? So lambda minus 2 is a factor. Then another factor is, therefore lambda minus 2 into, see, 1 into lambda squared is lambda squared minus 9 lambda plus 18 is equal to 0. Now you see that this is another factor. See, so I told you this is a quadratic. This factor is also quadratic. Now you have to change this to linear. Okay, how to do that? Product of the extremes is equal to sum of the means in that. That is, what is this? 1 into 18 is 18. Split 18 into all its factors, so that if you add, it will be minus 9. When you multiply, it is 18. So what is that? 3 into 6. I can write this as 3 into 6. See, minus 3 into minus 6 is plus 18, whereas minus 3 minus 6 is minus 9. So this can be written as lambda minus lambda square minus 3 lambda minus 6 lambda plus 18 is equal to 0. Now if you factorize that, take the common factors and factorize this, what is that you will get here is lambda minus 2, I will write it here, lambda squared minus 3 lambda minus 6 lambda plus 18 is equal to 0. So this gives you lambda minus 2, lambda minus 3, lambda minus 6 is equal to 0. So this implies lambda is equal to 2, 3, 6. So what are the characteristics? So lambda 1 is equal to 2, lambda 2 is equal to 3, lambda 3 is equal to 6. So these are the eigenvalues. For every eigenvalue, I can get hold of an eigenvector. Taking the eigenvectors into factors, I can form another matrix. With the help of that matrix, I can get hold of the diagonal matrix. That is my ultimate purpose. So finding the eigenvalues are very, very important. This is how we find it. Know that here the shortcut method are there. You can just go for finding the straight away finding the determinant value, getting the value of lambda is one method of doing it. Otherwise, as I gave you the alternate method, go for lambda cube. The formula is like this. So ultimately what I finish is, see, you can go for this. So the formula that you must go is lambda cubed minus, you can write this as lambda square into sum of the principal diagonal elements, then plus lambda into the determinant value of the minus of the principal elements and minus the determinant of it. You can use this formula to get the value of, get the eigenequation. Once the eigenequation is found, you can factorize and get the values of lambda. This is what we mean by eigenvalue. After finding the eigenvalue, get eigenvectors. Okay. So there are properties for eigenvalues. Eigenvalues, one or two properties I'll tell you. If lambda 1, lambda 2, here you see that 2, 3 or 6 are the eigenvalues of this A. The eigenvalues of the transpose will also be the same, 2, 3, 6. And if you take the inverse of A, then the eigenvalues of that inverse will be 1 by 2, 1 by 3 and 1 by 6. If we take A to the power of P, raise it to power P, then the eigenvalues will be 2 to the power of 3, 3 to the power of P, 6 to the power of P. So these are the properties, or some of the properties of the eigenvalues. Thank you.